All right, today we're going to look at the spinal cord and the spinal nerves. And remember, the spinal cord is part of your central nervous system. Those are the nerves actually in the spinal cord, and the spinal nerves are the nerves that are attached to your spinal cord. Okay. Now, just some facts about your spinal cord. Remember, it is thicker at the top, and it's going to get thinner as it goes down. So remember, it's attached to the brain up at the top, so all the nerves leaving the brain, that's going to be the thickest part there. And they branch off as they go down along the way. So if you remember with your vertebral foramen, it was really big up at the top, and they get smaller and smaller and smaller as you go down. Okay. The end of the spinal cord actually has no nervous tissue at all. It's just myelin. It's called your filium terminale. And remember, that is where your coccygeal bone is. And remember, your coccygeal bones are vestigial. There are tailbones, so we don't need that portion anymore. If you were actually a four-legged creature, a creature that had a tail, you would have a nerve that goes all the way down to the end, and that nerve's going to help you wag your tail. And the tails in those animals are used for balance. Okay. We've talked about gray matter and white matter. Remember, the more myelin you have around you, the whiter you are. So the nerves that give off a lot of electricity are going to be really insulated, so they're white. And in the brain, the gray matter was on the outside, while the really, really, really important nerves, the white matter, was on the inside. Well, the opposite of that happens with your spinal cord. In the brain, the white matter is on the inside with the gray matter on the outside. Because if your brain's going to get damaged, it's the outside of the brain that's going to get damaged. Okay. However, in the spine, since the nerves branch off the spine, the white matter is actually on the outside, while the gray matter, the nerves that aren't very important, they're not really going anywhere, are going to be on the inside. Now, all the nerves of the spinal cord are arranged into two bundles. If you could actually take somebody's head off and look down into their spinal cord, you would see two bundles. So you have a bundle here and you have a bundle over there. And these bundles are called tracts. Okay? So like I said, if you could look down into somebody's spinal cord, you'd see a circle with two other circles inside of it. Okay? And each of those is a tract. And each tract would have three bundles inside of it. And so each of those bundles is going to be called a funiculi. And you have two tracts. You're going to see you have the ascending tract, which is going to be mostly sensory neurons going up to the brain. Ascend means to rise. And the descending tract are mostly motor neurons. They're descending. They're going away from the brain. So you would have two bundles and three bundles inside of each tract: the posterior funiculi, the anterior funiculi, and the lateral funiculi. Okay. We're going to look at some important nerves that we have in all of these. And so the ascending tract is going to contain sensory nerves, and that's going to take information to the brain. And you would have a posterior funiculi, an anterior funiculi, and a lateral funiculi, three bundles within that tract. Okay. Likewise, the descending tract is going to contain motor neurons, and it's going to take information away from the brain. So you would have three bundles inside of that. So if you could take somebody's head off, you'd have two big circles with three smaller circles inside of them. So we're going to look at some of the important nerves that are found. There's obviously a lot more than these. These are just the nerves that the curriculum thinks that are the most important for you to know. Okay. So we are looking at the ascending tract, okay, and we're looking at the posterior funiculi. Okay. So these are all going to be sensory nerves, and you have two major sensory nerves. Now remember, structure determines function. So if you'll notice, their names are very similar. This is what I'm talking about, where you've got to be careful with these funky names. You have the fasciculus gracilis and you have the fasciculus cunatus. Their names are similar, so you know they're going to have similar jobs. Okay. These are both sensory nerves. Okay. The fasciculus gracilis carries information on lower body position and movement to the brain. Okay. Your body needs to talk to your brain to let your brain knows what it's doing. So when you're moving your foot, the information eventually goes up this nerve to the brain that says, hey, I'm moving my foot. Or if you're walking, that information is going to go up this nerve that says, hey, I'm moving my legs, I'm walking, am I doing what I'm supposed to do? So notice the funiculus cunatus, very similar name, so it's going to have a very similar job. Notice this carries information on the upper body to the brain. So when you raise your hand, this is the nerve that says, hey, brain, I'm raising my hand. So the gracilis is the bottom part of your body. The cunatus is the top portion of your body. Okay. But notice the cunatus also has another job. It carries information from the upper body relating to touch and pressure. Okay. And we're going to talk about what you've always called your sense of touch isn't your sense of touch. Okay? If I could weigh something on a balance, that's going to put pressure on you. That's your sense of pressure. Okay? If I were to take a piece of hair and put it on one of the balances back in the back, it wouldn't move. So hair touching your skin, that's your sense of touch. But a pencil on your skin, that pencil has weight to it. I would be able to measure that. That's going to be your sense of pressure. And we're going to look at more of that later. Okay. Now this is the lateral funiculi, still ascending tract. So these are still sensory neurons. Okay. We have three major nerves in this group. Okay. The first one is the lateral spinothalamic tract. Now look at the name. It's going from the spine to the thalamus. So it's sensory. It's going to the part of the brain. Okay. So it's going from the spine to the thalamus. And this is one of the nerves that gives you information about pain and temperature. Is your body hot? Is your body cold? Is something hot? Is something cold? Does something hurt? Okay. And remember, pain is your body's way of telling you something's wrong. Okay. You then have the dorsal spinocerebellar tract. So again, it's going from the spine to a part of the brain. And remember, the cerebellum deals with voluntary. It's somatic. And so notice it carries information from muscles of lower body to the brain. Okay. Cerebellum are going to be skeletal muscles. And so this is how the cerebellum and those skeletal muscles talk back and forth to make sure everything's working the way it's supposed to. You then have the anterior spinocerebellar tract. So notice very similar. Okay. You're just going to have to practice these terms and just remember which one does which. Okay. Notice these are from the upper body to the part of the brain. So names are similar, function is going to be similar, but they're two different nerves. Okay. So the dorsal goes from the lower body, the anterior goes from the upper body, which, anterior means, you can think of it as higher. So it's going to be the higher portion of the body. Okay. So dorsal spinocerebellar, skeletal muscles on the lower body talking to the brain, anterior muscles from the upper body talking to the brain. Which leads us to the anterior funiculi now. These are still all sensory. Okay. I hate it when it does that. So you have the anterior spinothalamic. So again, another nerve going from the spine to the thalamus. Okay. And this is going to carry information from the skin about touch and pressure. So when you feel hair on your face, this is the nerve that eventually is going to take some of that information back to your body. Okay. And then you have spinotactile. This is just one of those that you're going to have to remember. It's sensory, because spine is first. It just doesn't tell you what part of the brain it goes to. Okay. This is actually going to go to different relay stations you have in your body. It carries information regarding body position in order to keep body movements coordinated. And what we mean by body position is, am I sitting up? Am I sitting down? Am I spinning around? Am I walking forward? Am I walking backwards? Am I standing on my head? Okay. And so in order to keep you coordinated, your brain has to know, okay, which way am I moving? Because remember, you have your unconscious part of the brain and you have the conscious part of your brain. The conscious part of your brain is moving your skeletal muscles. Well, the skeletal muscles still have to talk to the unconscious part of your brain so they know what they're doing. And so this is some of the nerves that are going to be in charge of doing that. Okay. And if at any point in time you need to repeat some of this stuff, just ask to hit pause or reverse so you guys can pick up what you need to pick up. Now, those are all ascending tracts. So those are all sensory. Okay. So I'm going to take it back here. Okay. With your sensory, you have 1, 2, 3, 4, 5, 6, 7 nerves. And this is why we've been having the little test along the way, so you can kind of study a little bit at a time, because hopefully you've already studied the parts of the brain, or you're going to have already studied the parts of the brain. So come the test, you only have to review it. Okay. You will have studied the cranial nerves, so come the test, you only have to review it, because this is probably what you're going to have to spend your most time focusing on with the test. Okay. Now we have the descending tract. Okay. The descending tract is going to be all motor nerves. It's also divided into 3 funiculi, a lateral, an anterior, and a posterior, but we're not going to divide them up that way. You just need to know these 3 major nerves. The first one is rubrospinal. Now notice in these, spinal is second, and the other spinal was first. So this lets you know it's going to the spinal cord. So it's coming from the brain to the spinal cord. So this is how your cerebellum talks to your skeletal muscles. It's eventually going to leave, this nerve is going to leave your brain, going to go down your spinal cord. It's going to branch along the way. But your vertebrospinal tract carries information away from the cerebellum to the different skeletal muscles. You have hundreds of nerves within this bundle. You also have the corticospinal. Okay? So cortical referring to the cerebral cortex, you know, your different lobes, the frontal lobe, the occipital lobe, things like that. So this is going to carry information from the cerebral cortex to the spinal cord. And then it'll branch off depending on where it needs to go. And then you have tectile spinal. This is going to allow for your optic and auditory reflexes. Remember, a reflex is something you do to protect you. Okay? It's a unipolar neuron. And optic reflexes would be like your ability to have hand-eye coordination, your ability to follow things moving towards you. So when you see something coming at you really fast, your ability to respond to that. Remember, auditory reflexes are going to be sound-driven. So like an optic reflex would be me throwing something at you, and you see that happening, and that causes a reflex. Auditory reflexes would be like hearing somebody coming up behind you or hearing a door slam and causing you to react. And remember, these are all part of what we call the fight or flight reflexes. You're either going to fight off what's coming at you, or flight, you're going to turn around and try to escape. Now, so these are all parts of your spinal cord. Okay? So this is all central nervous system. What we're going to look at now are going to be your spinal nerves. Okay? These are part of your peripheral nervous system. They branch off your spinal cord and go to the different parts of your body. Okay? You have 31 pairs of spinal nerves. Now, we're not going to do all 31 pairs. Okay? We're just going to look at some specific ones. And your 31 pairs of spinal nerves are divided into different networks, and each network is called a plexus. So you have a cervical plexus, which obviously is going to have something to do with your cervical nerves. So it's going to have something to do with your neck, your head, that region there. Brachial, like your biceps brachial, these nerves are going to have something to do with your arms. Your lumbar, like your lumbar vertebra, these nerves are going to have something to do with your lower back and your hips. And then your sacral is, remember, your tailbone, and these nerves are going to have something to do with your legs. Okay? So you have 31 pairs of spinal nerves. We're not going to do all 31 pairs. We're just going to look at some of the specifics. Okay? So in the case of your cervical plexus, you guys know that the cervical vertebrae are the ones in your neck. So obviously nerves that branch off there are going to have to stay in that area. So these are nerves that go to your neck and your shoulders. The first one there is your cutaneous nerve. Okay. Remember, anytime you see cutaneous always means the skin. So this nerve has something to do with your skin. And you're going to see the term innervates a lot. Innervates means it goes to, or it takes information to, or it's coming from. Okay. But the cutaneous nerve innervates the skin of the neck, jaw, and shoulders. This is a sensory nerve. Okay. Your skin doesn't move. Okay. So when you touch your face, when you touch your jaw, when you touch your neck, when you touch your shoulders, this is the nerve that takes that information to the brain that says, hey, something's touching my face. Okay. Motor nerve is obviously going to be movement. Something is going to move. So it innervates the neck muscles. So when you nod your head, when you move your head, when you shake your head, this is the nerve that's telling those muscles that to move. And then you have the phrenic nerve. The phrenic nerve is interesting because it tells your diaphragm to move. This is the nerve that causes you to breathe. But it branches off at your neck. Okay, why it doesn't go down further and branch off in your thorax somewhere, scientists don't know. But phrenic refers to diaphragm. And so like when you get the wind knocked out of you, what you've actually done is you've hit this nerve and you've stunned this nerve. And so it takes a second for it to kick back on so that you can breathe in and out. So this is a sensory nerve, this is a motor nerve, and this is a motor nerve. So even though this one's called motor nerve, obviously something's going to move. Okay? So these are all part of your cervical plexus. Okay, they're going to deal with the neck. Sorry, this is really bouncing around, but my hand is getting really tired holding this. I'm doing this on my tablet. Okay? You then have the brachial plexus. So if you remember, this muscle right here is called your biceps brachial. So you know that these nerves all have something to do with your arm. They branch off about here at your shoulder, and these nerves are going to go down your arm. Okay? So the first one, well, there it goes, nerves that go down your arm. The first one is called circumflex. Okay. Remember your joint movements, like the ball and socket. When you circumduct, you move things in a circle. And you can take your arm and move it in a circle. And flex means to bend. So this is the nerve that innervates your deltoid muscle. Remember, that's the muscle in your shoulder. And it lets you move your arm. So this is the nerve that tells you to raise your hand. Or this is the nerve that tells you to swing your arm in a circle. Okay, so this is going to be a motor nerve. You then have the musculocutaneous. This is a mixed nerve. It is a motor and it is a sensory. Remember, cutaneous always means skin. So it innervates the biceps. That's the musculo part. Okay, this is going to be the nerve that tells you to bend your arm. But it also is a sensory nerve because it innervates your skin. So when you touch your biceps or you touch your shoulders or you touch the upper part of your arm, this is the nerve that sends the information to the brain that says, hey, something is touching me. Then you have the ulnar. You know that the ulnar bone is the one that runs down your pinky side. And so if it's all the way down here, this nerve is going to go all the way down here, and it's basically telling the muscles of your forearm what they need to do. It's like when you twist your hand back and forth, this is the nerve that's telling it to do that. And then the radial, you guys know, is the thumb side. Okay, sorry, it's shaking like I said, my hand's getting tired. This innervates your triceps. Okay, so even though it's called the ulnar, which is the lower arm, it actually passes through your triceps. So this would be the nerve that tells you to straighten your arm. And then it goes all the way down to your hand. And so this is the nerve that would tell you, how to move your hand around. Bend your fingers, straighten your fingers, hold a pencil, things like that. Oops, sorry. Now, you have another plexus that we're skipping. It's the nerves that make up your thorax. It's called your thoracial plexus. There are a lot of nerves in there, and so we're just going to kind of skip that one. And we're going to go down to your lumbar plexus. And remember, your lumbar is your lower back. So you can see here in the diagram right there, these nerves are going to branch off of your lower back. Okay? And so this is going to be like your hip and your upper leg. Okay? So if you'll notice, these are nerves that go to your thigh region. And you guys know the bone of your thigh is your femur. So notice most of these deal with the term femur. So you have lateral, femoral, cutaneous. So femoral lets you know this is your thigh. Cutaneous lets you know it's your skin. So when you touch your thigh, this is the nerve that takes information to the brain that says, hey, something is touching my thigh. Then you have the femoral. This one is motor. This one actually innervates the muscles of your thigh and hip. So this is the one that tells you to move the muscles of your thighs. This is the one that tells you to move the muscles of your hips. And then you have genitofemoral, which lets you know it innervates the skin of the genitals. Remember, your genitals are very sensitive, okay, because it's part of your reproductive system. And so this is a sensory nerve. It's skin. Okay. So we've got sensory, motor, sensory. They all deal with femoral, so you all know that they're in the thigh region. Which then takes us to our sacral plexus. Your sacral is your tailbone. Okay? So the nerves we just looked at dealt with our thighs. So obviously these are going to deal with our lower legs and our feet. Okay? So these are the nerves that are going to go down your leg. Okay? Your first one is your cosyngeal nerve. And like we said, this is your tail nerve. This has absolutely possibly no purpose in humans. So for most of us, it never reaches threshold. We have no tail to wag. You did have a tail as a fetus, you could wag it, but as your body grew, that got incorporated inside of your body. So you've heard of people born with tails. It's just their coccyx bone. It didn't actually get incorporated, and it's just a matter of surgery of putting it back into place. Now, you've all heard of your sciatica nerve. It's the largest nerve of your body. It actually runs down the back, down your thigh, and it splits. Okay? And so it divides into two smaller nerves in your gluteus maximus. Your tibial nerve obviously has to do with your tibia, and so this tells the muscles of your lower leg what to do, like your gastrocnemius. And then the peroneal actually tells your feet and ankles what to do. And so those are all of the nerves in that packet. If you need to rewind this to get anything that you need, and I thank you, and we will see you as I stick my fingers in there tomorrow.